Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavors of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your technical questions answered, and contribute to the community forum. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our construction, tech, or weekly Global Passive House Showcase webinars. Well, welcome to another special episode of Passive House podcast with a component episode. And who we got this week, Zach?
We have two leaders from PROSOCO here, Paul Grahovac and Pat Downey. I just had the chance to sit down with both of them and learn more about PROSOCO and their journeys to this world of airtightness and water tightness and fluid applied barriers, and dive in a little bit into the leadership role that PROSOCO has played in the North American Passive House movement for a while, and learn about some cool projects. So I think people will enjoy this one.
Yeah, I think they will. And there's some really cool stories in here about the people behind these projects and the products, but also some great building science to get stuck into here as well. So definitely learn something in this episode. All right, let's get into it.
Welcome to this special component podcast episode of the Passive House podcast. I'm really excited to have Paul Grahovac and Pat Downey with PROSOCO here to join me today. Welcome, Paul and Pat.
Thanks, Zach.
Yeah, absolutely. So PROSOCO is a champion sponsor of Passive House Accelerator, so we're really grateful for that support. And I've been aware of PROSOCO since my very early kind of formative years in Passive House, because the very first Passive House that I visited in and learned about Passive House around was the Karuna House in Oregon. And that was, I think, built about 10 years ago. And I was first introduced to the red goop that I think we're going to be talking about a little bit later on that project. So it's a really, like I say, a pleasure to connect with both of you and have a chance to talk about your journey and what's going on with PROSOCO in the marketplace. So maybe we could start with that, the journey. Paul, could you start by talking about how did you get involved with PROSOCO?
Sure. I was only a few years out of law school. I was working for a law firm doing construction defects litigation, and our corporate section asked me to go over and talk to a chemical products company about new developments in occupational safety and health, material safety data sheets, environmental compliance, and product liability. For years, it was only big chemical companies with intense processing systems that were subject to that kind of regulation. But that has all changed, and this was at a time when it was all changing. And they kind of liked working with me, and so they thought it'd be a good idea for me to come on staff, which I did. And after about 5 years, I got everybody trained up, and I kind of got concerned that I might be working myself out of a job. So I went out to a U.S. Department of Energy Research and Development laboratory, where I was an environmental lawyer for a Superfund site 3/4 the size of Rhode Island for 4 years. And then I switched over to something called technology transfer and research and development, where I helped put together research collaborations, develop patents, and license technology into the private sector from the government lab. And then after that 10-year period was over, I moved back to Kansas City and was able to get on staff with PROSOCO. Unfortunately, about that time, they decided they wanted to become an air barrier company, and so I became expert on that. And most people know me as manager of code standards, testing, and field support, because that's mostly what I do. But I am still the company attorney, a risk manager, and I do new business development, which is licensing technology in, such as the technology we're talking about today.
Great. That's a lot of hats. You wear them well.
Job security.
Yeah, no doubt. Right. That's probably no longer a concern. So, Pat, what about your story?
Well, I'm from the window and door industry. Started selling windows and doors installations. Single family retrofit is my specialty. Then got into manufacturing windows, running service crews all over the Northwest. And then company out of British Columbia, Starline, hired me away and wanted me to be a project manager for Washington, Oregon projects. And was doing that, managing 12 to 15 projects at any given time. And then we had this big retrofit project in Portland, on the Portland Towers. It was 3 towers, 20 some stories each. We had a special pan system. We were distributing this tilt and turn door system and window system. And we started installing. We were using urethanes, peel and sticks. Things were looking really good. And then we started testing. And I failed 5 out of 6 tests. And that's where I started getting gray hair. This is in 2006. And the company that we were distributing, Inotech, said, hey, you need to look at this red goop. We just did a condo project on Vancouver Island on the west side, which is an extreme weather area. And they said they had no leaks. So I was introduced to the guys at Building Envelope Innovations, BEI. That was Tom Schneider and Ron Tatley. And they did their dog and pony show at the project. And they said, you're having adhesion issues. None of our urethanes, none of our peel and sticks would stick to the old concrete. And so he says, we need to start testing. And that's where I first heard the phrase, if you're not testing, you're guessing. And we assumed things would stick, but they weren't. And so he applied some products to various substrates that we were dealing with. And a week later, I called my foreman and I said, start doing pull tests. And he goes, Pat, this stuff's sticking like nobody's business. So I grabbed my envelope guys from Canada and flew them down to take a look at this product. It was new on the market. It was developed by Tatley Grund, a restoration contractor out of Seattle. And that's where BEI spawned off of them to market and manufacture the products. Long story short, we started using it. The big thing was that my guys could work on damp surfaces, rainy days, because it lets moisture vapor out, and it's simple, and it doesn't take up much room in the rough opening. And so I became a huge believer and started pushing it on our projects. And then in 2008, BEI hired me away from the window manufacturer. And then in 2010, actually, I think it was 2009, PROSOCO saw us in Naples, Florida, with one of our test chambers. We had a mini test chamber. And Paul could probably talk more about that. I think he was there. I was not.
Well, yeah, our distributors are calling us up and said, there's these guys pulling around this hurricane test chamber, and they're, kicking ass and taking names here. You better figure out what's going on. So the president of our company is an architect by background, been in construction all his life. He and I went down there, and they showed us the test chamber. And I said, well, I'm a member or representative to the Air Barrier Association of America. And to play in that league, you've got to show virtual air tightness at 75 pascals of pressure, which is about a 25 mile an hour wind. So can we just cut to the chase and, tell me, whether you can perform anywhere near that? And Ron Tatley is kind of soft-spoken, and he said, we think the systems need to stand up to the most serious kinds of weather. And so what you're seeing tested here is 2,900 pascals with water to simulate the 160 mile an hour wind-driven rate of a Category 5 hurricane. As you can see, there's not a drop of water getting past the installation. I looked at my shoes. I said, I think that'll do.
Yeah, that was one of the concepts of Tatley Grund and BEI is the window test to failure. In the window industry, we always test to pass, which that's a different concept. And they had weather stations on top of some of the towers they were working on in Seattle, Portland. We get 80 mile an hour winds throughout the year. So they wanted to double it as an insurance policy. They're going into retrofit projects, and the consultant architect was telling them, put back in them, which failed. And so they wanted to come up with a another system that was higher performance, easy to install to make the installer a champion. And then it morphed in 2010. We partnered with PROSOCO. And then in 2016, I actually jumped over to the PROSOCO side and we mothballed BEI.
You know, it's interesting when he's talking about the weather station. It reminds me of a couple slides in the presentation. There's one called the product wish list, which is 12 or 18 different factors that Ron Tatley and Tom Snyder listed before they ever started thinking about what material would satisfy these needs. They looked at the needs first. And I had just come from Lockheed Martin at the National Lab, who of course are champions in systems engineering, where you look at the need and what does that aircraft need to be, and you come up with some pretty startling changes in the technology, such as a stealth aircraft. And so it's ironic that I moved from one systems engineering group to another.
That's really interesting. I think that one of the things that's also really compelling about the story is my understanding is that those early days with BEI was you were essentially rescuing buildings, right? I mean, do I have that right?
Yes. Going in there and basically having something that the big issue we have is installing details for windows, doors, through all penetrations is difficult. And this actually was a game changer. Going in on projects, it's raining and the general contractor needs to keep to a schedule. And I would show up and say, it's raining today, but you could be applying this product right now and not have any issues. But it was simple. I can take somebody in a half hour and train them how to be efficient with the materials. And it actually started morphing into the Passive House group when we did the Mini B back in 2009.
Oh, Joe Giampietro's project.
Correct.
Yeah.
And Dan Whitmore.
So, right. So those were like, Joe and Dan are a couple of the pioneers of Passive House in the Northwest. And so those are really, that Mini B, though small, is an iconic building. Another iconic building in the Northwest is the Bullitt Center, which was, I think, the first full living building challenge, fully certified building. It's in Seattle. And you all played a really important role, both on the building, but also in interacting with and delivering on the Living Building Challenge's Red List. So could you talk a little bit about that and what that story is?
Yeah. So I was dealing a lot with Miller Hall, which was the architect on that project. I was doing a lot of fire stations with them and other buildings. And then RDH was a consultant on there. And I get a call from Katie from Miller Hall. And she said, Pat, we want to use your products, but your Cat 5 has phthalates in it and it's plasticizer. And she goes, we really want to use it. I also talked to Michael Kramer and he said the same thing. So I went back to Tom, who was working hand in hand with our chemists at PROSOCO, and said, hey, it's on the red list. And, at that time, I think there's 325 red listed items, something like that. And so they started talking about it, thinking, this isn't, what's going on here. And so then they actually said, you know what, we can actually get rid of the phthalates. And so went to a different plasticizer that didn't have any phthalates. It qualified. And basically, we got back on the project and helped there. I was out there quite a bit training several people on how to apply products. And out of all the companies that were on that project and were able to alter their formulations from steel studs, concrete, pipe fittings, windows, gaskets, you name it, we're one of the only manufacturers that didn't revert back to our old formula. We still are phthalate free, and we're still a Living Building Challenge 3.0 or 3.5 qualified to this day.
Yeah, and I'd like to comment on that, if I might. I was, around when this was going on and hearing about it and such. And so I said, well, what are phthalates? Anyway, what I learned was, like some of your audience might right now have a smartphone in their hand or a mouse, or they might have their hand on their laptop. They're touching something that contains phthalates. Every piece of plastic, every paint, every coating that they come into touch with contain phthalates. Now, when they're in concentration, they can cause reproductive damage. So it's great to see, the red list people getting rid of them, but to take them out of a coating or a whole product line, fairly extraordinary. And I think we're just real fortunate we're able to find something to substitute.
Yeah. Well, and for listeners, I think probably a lot of people are aware of the red list, but the purpose of the red list is to impact the practice of manufacturers. Partly they're concerned about what's going on with these specific buildings, but they also want to be an influencer of change and to help kind of encourage manufacturers to change their practice. And so it is such a powerful story that not only did you make the change in formulation for the Bullitt Center itself, but now that's just what you do. And so I think PROSOCO has rightly become kind of a poster child for the red list and a real success story for the ILFI, which I think has been that's been really fun to watch develop. From my seat in Seattle, I had an office in the Bullitt Center when Hammer and Hand's office was there, and I got to enjoy phthalate-free life. Although my mouse was a problem, I guess now I'm learning. So great. Well, I know you've been involved in lots of passive house projects and net zero projects and other. We just mentioned an LBC project. Could you share some examples of those sorts of projects, and particularly with an eye to cost efficiency?
Yeah, I had a large project on Bainbridge Island called Grow Community, and they were using a bunch of different buildings. They called them roadhouses, which were apartments or condos. Then they had townhomes, and then they had single dwellings as well. In this community, your parking is at the end. It was a bike community trying to be net zero, no impact on the grounds or anything like that. And I did a presentation at the Echo Guild Build. And one of the main architects at this project called me in and said, we're having major issues with these buildings we're putting on. We're using different types of peel and stick as a WRB and building paper. And they said, we spend half our time after we construct the building and do a blower door test chasing leaks. And we would like to do a time study of the Cat 5 system on this one building. And if you get that, you get the second phase. And so we went out there, I trained them, it was on OSB. The guys went out there, and as soon as they applied the products, then they started doing their cladding and all the interiors, and they did their blower door test and had no issues. They passed it easy. And so when they finished the time study, the labor and material costs, it was actually cheaper than some of the building paper systems complete from beginning to the very end, just because they didn't have to chase any leaks. Plus, with the different interfaces with roofing to wall interfaces, through wall pipes, windows, it's sealed up 100% because it's all monolithic now. You're intimately bonding these through wall penetrations, pipes, electrical boxes, and windows. You're intimately bonding everything to the air barrier. And so, or weather barrier. And so you're not going to have any issues. As well as that Corona house you mentioned in the Portland area. I can't remember what numbers they hit, but real simple to hit, I think, half of the passive house standard.
Yeah, that sounds right.
Not correct.
Yeah.
So real simple. And then we've been involved with a lot of ADUs, passive house ADUs throughout Seattle, and with great success. In fact, the building was out exposed for 2 years because she ran out of money and couldn't put the cladding on. And she said, the cool thing about this is we went through 2 winters and didn't leak any air or water.
Wow.
So.
Well, and I know that you also have what you call the accidental passive house. Could you tell us about that one?
Yeah, I'll take that one because I gave it that moniker. Pretty amazing situation. A high school, new construction, Bellingham, Washington, 264,000 square feet. And I know most of your audience is aware, but I'll just kind of give some of the background so everybody's on the same page. For the air barrier code requirement, a designer and contractor have a choice. They can either choose to install an air barrier system in such a way that the code official is convinced that they have met the requirement for installing an air barrier system, or they can do a blower door test to prove it. And as a speaker last week at the Air Barrier Association annual conference says, almost no one does a blower door test. But this architect decided that they would go for the code option, blower door compliance. And again, I'm not going to go through what all these numbers mean, but 0.4, you can hold that in your mind, CFM, but just hold the number as a number of tightness. 0.4 is the code number for if you elect to do the blower door. The Passive House Institute US standard is 0.08. So the Passive House standard is 5 times tighter than the code standard, and nobody does the code standard probably because they're not going to be able to make that. So Passive House is quite a bit tighter than what's being built out. Anyway, so they put the system in. It was the PROSOCO ArcGuard system, the fast flash, air dam, Cat 5 and such. And they put the blower doors on it, and without any leak chasing at all, they blow 0.095, which is almost 0.8. And what we find is, somebody has typically left a window just cracked a little bit, and you go around and roll that shut, and wham, you're below 0.08. So, and then as to the Passive House Institute, which is headquartered in Germany, they have a different system. They go for air changes per hour. 0.6 air changes per hour is their standard, and the test result was 0.39. So clearly whooped the Passive House standard there when they're just trying to do code. So I put a slide together, and I have it in a presentation, and I tell our field people, if the project doesn't want Passive House performance, they need to bring a drill to the blower door class.
Thankfully, that's probably not very common. The drill. This is a great story on many levels. One is that the team was able to make the code requirement and easily beat it and make Passive House. What are the benefits to the building and to the people who will be in it due to this accidental Passive House level of airtightness?
Well, it's too bad I don't have my handy dandy list up, and while I'm finding it, I'll tell you why I named it. I named it the Designer Series because I went to buy a new set of the building codes from the Code Council, and I see that the International Code Council was selling their code sets as a Designer Series. And so I said, well, heck, if a code book can be a Designer Series, then we can have, Designer Air, Abundant, virtually allergen free. We can have Designer Clean because there's no dust infiltration. You mentioned not ever having to dust in your house again. Designer Resilience. Many reports of polar vortex and Passive House, people maintaining 55 degrees with no power, no gas. And the list goes on. In Minneapolis, Hook and Ladder is a significant apartment complex built almost literally on top of 4 railroad tracks. And the noise evaluation indicated the occupants would not be impacted. So you've got all of this vacant land up and down the railroad tracks in this country that hasn't been built on because of the noise, and sitting there really waiting to solve the not in my backyard problem. Mm-hmm. Because guess what? You're not in anybody's backyard. You're in the railroad's backyard. There's hardly anybody around. Anyway, the list goes on, but those are just some of them.
This has been a really great conversation, and I really appreciate being able to hear these stories. Before we close up, is there anything else that either of you would like to add or share? with the audience?
Well, because I come from a code background, and I gave back when we got into air barriers, I gave 120 presentations in 3 years to architect groups around the country, and I got a feel for what they wanted to hear, and what they wanted to hear was 10 years. And we've got forensic reports where we've sent forensic architects in to a project that was done in 2005. We send them in every 5 years and deconstruct a portion of the building to assess and verify that the material's there. It looks the same as when it was put there, and it's functioning the same as it originally was intended to. So that's one thing that architects ask for. And the other thing they ask for is, well, what about the code? Where's the code? Well, fluid applied, rough opening treatment, flashing has been recognized in the code since the 2018 code. And then in the most recent version of the IRC, the residential code 2021, they've actually codified the air dam, the interior air and water seal that was developed by BEI, because guess what? Builder grade windows leak almost immediately upon installation. And if you don't have a watertight, airtight, rough opening, it's going to leak right into the wall assembly. And if you don't have an interior seal, it's going to go backwards into the building. And so that interior seal has now become codified in the IRC.
That was one of the biggest takeaways from my time at Hammer and Hand, actually, was this notion that you just need to assume that windows will leak. And so make sure that you are detailing the rough openings accordingly and plan for it, and then you're in good shape. And the PROSOCO products were the go-to way that Hammer and Hand was doing that.
Yeah, that's the genius of Ron Tatley right there.
Yeah.
And Stace Grund is part of the group with the Tatley Grund. I might add too that windows are. I'm a window nerd. Been doing windows since the early '90s, and they're made nicely. People try to make them properly, but they get put out on a job site. So that's one of the biggest issues with windows. And I was involved with training Hammer and Hand at the very beginning when Sam said, "This is the system, you're going to use it, blah, blah, blah." Mm-hmm. And the system's so simple, but there's always tricks. We used to call it idiot proof, and then we found the better idiots. And so now it's idiot resistant. But the PROSOCO people, the reps, we like to be involved on the jobs. I've helped several homeowners build their house, their passive house, or net zero, where they're using the products themselves because they can't find any labor. The same with contractors. I just trained a group out of Portland that are self-performing, and I spent an hour with them, and now they're applying products. So the other thing I would say, and it's always been this way, is we want to be hands-on on the project. So if you're ever building anything, give us a call. I cover the whole Western US and support managers. I'll come out to your project and train you how to put the products on properly.
All right. Well, again, thanks to Paul and Pat and PROSOCO, and it's been great to chat with you, and we'll look forward to the next cool projects that you guys are involved with.
Thank you.
Thanks, Zach.
All right, so that was Pat and Paul from PROSOCO. Great stuff. And as I said at the outset, some really cool learning about not just the building science, but a bit of an insight into how some of the standards are being applied or not in some parts of the states. But that's not uncommon. I mean, people typically will do the bare minimum, and I thought that was an interesting story about most people choosing not to do a blower door test if they can get away with it. But when you do, and you're working with a team who knows what they're doing and is using good products, the results are pretty amazing.
Yeah, I love the accidental passive house story. And I mean, these fluid applied membranes and products are, I mean, they're sticky, but aside from, and so I think they'll stick onto clothes and things. So maybe that's a hassle, but the reality is that everything else about them is simple, right? So they're easy to see. They're when they're applied, it's easy to see if they've been applied well just by looking at the coverage and the color. And so you can really imagine just a competent crew putting the stuff on and accidentally creating a passive house level airtight layer.
Which of course is a great thing if you know that and you're designing the rest of the building appropriately and having good insulation, good vapor control, good ventilation. So we're kind of assuming all that's going on as well, because airtightness is definitely a good thing. I'm always a little bit cautious about people doing excessive airtightness accidentally and not having done ventilation or thinking about what the vapor is doing. But that's not the case for these projects. So it's an impressive result that shows just how far you can go with what is often the most challenging aspect of passive house, just by having a crew who knows what they're doing with good stuff. The other thing that I found really interesting was talking about the rough openings and sealing around the windows when installing the windows, and the assumption that the windows will leak at some point. So it's not a question of if, but when. All window frames will leak. Now, the way that we tend to deal with that in our part of the world is still hang windows on the outside of the building so that when they do leak, they don't leak into the structure, but they'll leak out into a cavity, or they'll sort of leak on the outside of the thermal envelope of the building. But that means your window is not in line with the thermal envelope, so you're not getting any of the benefit if you have a half decent window, particularly thermally broken. I mean, I've seen details where they're thermally broken frame and they're not getting any of the benefit of the thermal break because the whole thing's sitting outside. So you've got an even bigger thermal bridge by virtue of having this window completely not in line with the insulation. It's products like these liquid applied membranes and what PROSOCO have that allow you to have some reassurance. And I think he talked about basically creating a complete seal around the hole that the window is going to go into, so that if and when the window does leak, it's not going to get into the timber or the structure.
Yeah, that's exactly right. So, and this was, I was introduced to all of this when I was first getting introduced to Passive House back at Hammer in Hand. And I think
I heard Hammer in Hand got a mention there.
Yeah, I know, right? Any episode is not complete unless I unless I talk about Hammer in Hand. It was a formative time, okay?
It was,
and for me anyway. We're in the Pacific Northwest. It's wet. So one of the reasons that PROSOCO's products really work here is that they can be applied in wet weather. All the rough openings in these projects that Hammer and Hand were doing were coated in this fluid applied membrane. The sill was angled outward so that any moisture that leaked through the window or just hit the surface of the window and fell off of it would then drain off and then there's another, membrane that would be integrated into that sill that then would allow the water to flow harmlessly away from the building. Yeah. There are different kinds of kind of grades and permutations of the fluid applied red goop that work in different kind of specific applications, but they're all then create this sort of monolithic, pretty much foolproof, airtight and watertight barrier.
Yeah. Impressive credentials around Living Building Challenge. I'm glad you covered that off because that's not an easy thing to get. It's the red goop is not on the red list, which is good to know. And that came about because of a particular project, but then the decision to stick with that and say, well, there's no point in putting these chemicals back in to the product if they're not needed, and having having that status gives people a lot of comfort when they're specifying products like this, to know that they don't have, or they've got fewer nasty chemicals in them.
Yeah, well, you can imagine the International Living Future Institute was really excited about this story too, because it was exactly why they created the Red List.
Yeah,
was to help, to play a role in transforming practice by manufacturers. And PROSOCO stepped up.
Yeah. The other thing that came, a couple of things. One is very interesting to have a trained lawyer involved in a project, in a product like this. I kind of think of lawyers as being pretty risk averse, and someone who's going to want to make sure that everything's done properly. And when we're dealing with anything to do with leaky buildings or moisture going through buildings, to have someone with that law background so enthusiastic about it, I think speaks volumes as an endorsement for the product. So I thought that was interesting. And as I said before, when you're working in this space, I think in our previous episode we mentioned just the expertise, the level of skill and knowledge that you often find with some of these product suppliers and what would otherwise be a salesperson is always quite fascinating. You get some highly skilled, highly trained people on a building site by virtue of some of these product suppliers. And I also really like he had a little saying there, I think it might have been, was it Paul? I can't remember who said it, but if you're not testing, you're guessing. And I really like that as a philosophy, as an idea for buildings, because so few buildings really get tested, and we emphasize the importance of commissioning for things like ventilation systems, and airtightness testing. It's just such a great way to quantitatively measure the craftsmanship and the quality of the building. Otherwise, you're just guessing about how well the building's been put together.
Yeah, it's so true. Back to to Paul's background as an attorney, I think that's also just a reminder that the initial application of these liquid applied membranes was in these basically this really horrible situation where a big buildings were failing because the windows were leaking, and they were leaking into the building envelope, and there was basically catastrophic building failure going on. And so Tatley Grund, my understanding is Tatley Grund was going in and remediating these terrible problems and figuring out how to shore up and then apply these membranes into the rough openings, so that theoretically you could even put the same windows right back in, but it would be harmless because the envelope was prepared to deal with that moisture now. So there is this, I think it makes a lot of sense that one of the key spokespeople and leaders in the organization does have that risk averse legal background, because it was all about dealing with tough problems and figuring out how to make them bulletproof moving forward. Yeah,
all good stuff. Well, it's great to have the support of all our sponsors, and I really like the alignment of those products and services that they offer, and the fact that we can do full episodes like this that are still really educational and still really beneficial, rather than just having people that aren't aligned with what we're trying to do. So it's great to have these guys as part of the community.
Yeah, it is definitely.
Awesome. Hey, well, thanks for that, Zach, and great to squeeze another bonus episode into the series. And I think coming up next, we'll have a back to the regular schedule and then another interview.
Absolutely. Thank you, Matthew.
All right. We'll see you next time on the Passive House Podcast.